Earth, home to a vast number of creatures, some big, some small. Since the dawn of life, the creatures inhabiting this world have changed, grown, and advanced, becoming ever so different. 3.8 billion years of genetic variance has brought life from single-celled organisms to mankind as we know it now. But why are we the only ones? What about our close ancestors with whom we shared so many similarities? If we were so alike, why don't they remain? This raises the question, what happened to the rest of our genus? As tragic as it can be, extinction is not a rare event. Even before modern man, it occurred regularly in nature. Factors such as climate change, meteor impacts, disease, and invasive species have all played a role in the process. So what exactly was the straw that broke the camel's back for our primitive forefathers? Before we look at how they died, let's look at how they lived. We'll start by viewing a rough time estimate of their existence. I prepared a timeline which includes nearly all considered species in the genus Homo. In red are species whose membership and identity in the genus is almost certain. The certainty of these species is based on plentiful amounts of fossils and evidence found. This being said, we generally have more knowledge and can provide more answers about these species. In yellow are species whose membership in our genus is questionable or uncertain, and whose identity may match that of another species in the genus. The lack of evidence keeps mankind from certainty of these species. With that being said, we have less knowledge on said species. With such little known about the species in yellow, I've decided to omit them from my research on extinction causes. How can you know how they went extinct if science has yet to confirm their existence or individuality? I will instead focus on the species in red, for I can provide more accurate information in regards to them. Shown by these rough depictions are Homo habilis, erectus, heidelbergensis, neanderthalensis, and sapiens. Going chronologically, our lesson will start with Homo habilis. Homo habilis, aka the handyman, is thought to have lived from 2.4 to 1.4 million years ago. Habilis males were an average of 4 foot 5 inches tall and weighed about 70 pounds, which is quite small when compared to modern man. Despite the stature, habilis had very strong but equally small teeth and jaw. This adaptation likely gave them a versatile diet, including leaves, woody plants, and even animal tissue. Further studies show that Homo habilis lived and hunted in small groups, which would have likely been a response to the increased number of predators in the savanna. When compared to modern humans, the brain size of Homo habilis was quite small, coming in at 650 cubic centimeters, as opposed to modern human brain sizes of 1350 cubic centimeters. Although it may seem small to us, it was quite large in its time. Although far from the top of the food chain, this larger brain allowed habilis to learn and grow as a species. Ultimately, however, it would be the size of the brain that predisposes habilis to extinction. A point had been reached where intellect and intelligence became necessary to survive. As time progressed onward, more hominid species began to emerge, and with larger brains. Habilis could in no way compete with these more intelligent species, whether it be in hunting, scavenging, or even fighting. Up next we have Homo erectus. The upright walking man is estimated to have lived between 1.9 and 0.5 million years ago. Erectus stood at about 6 foot tall and weighed around 150 pounds. Erectus was the first hominid to have body proportions greatly resembling modern man. His arms were shorter and legs longer, which adapted him to ground travel and running. Erectus experienced a hair loss and development of sweat glands, allowing the use of communication through speech. Studies of erectus bones show that their pelvis and ribcage were narrow, meaning they had a smaller gut and required more nourishment through meat. They also possessed a brain size of 860 cubic centimeters. The most significant part of Homo erectus's lifespan was the taming of fire. This led to expanse, and in turn, speciation. It is theorized that the Homo erectus that expanded to Asia evolved linearly, creating no branches and therefore an indistinguishable line between extinction and evolution. However, the Homo erectus that stayed in Africa may have faced a minor extinctionary event. It is theorized that the Homo erectus's loss of hair directly exposed the species to more radiation from the sun than ever before. Although it may not be what we consider lethal, it could have had adverse effects on them, considering their lack of genetic adaptations. This may have been what spurred the speciation of Homo erectus in Africa, eventually leading to Homo sapiens. Homo heidelbergensis is next on our list. This species lived approximately from 0.7 to 0.2 million years ago. Heidelbergensis was the first species of our genus to live in colder climates and build shelters. This ability to construct primitive housing was no doubt derived from the further increase in brain size, which was now 1200 cubic centimeters. It's a bit tricky to explain Heidelbergensis. Essentially, Heidelbergensis is a very late version of Homo erectus. It could even be argued that this is the species that first left Africa, depending on your opinion of when and how erectus evolved. In a sense, for the sake of simplicity, we could interchange the late Homo erectus with Heidelbergensis. If we do this, we see that just like erectus, Heidelbergensis either seamlessly evolves in Asia and Europe, or potentially branches and becomes extinct in Africa, possibly due to the same reasons that erectus could have gone extinct there. Our last relative in our genus is Homo neanderthalensis. The Neanderthal lived from 400,000 to 40,000 years ago in Europe and Asia. They stood at around 5 foot tall and weighed around 130 pounds. Neanderthals used tools and fire and made shelters and clothing. Their brain also exceeds ours in size, measuring 1,600 cubic centimeters. However, it has been revealed that they have a larger area of the brain devoted to sight, and when this portion is subtracted from the whole, their brains are left smaller than ours. There are 3 explanations to explain the extinction of the Neanderthal. One is starvation. When the large Ice Age animals went extinct, Neanderthals may have starved as a result, since they were built to hunt these creatures. They did not have early food trade networks which kept the sapiens thriving under these conditions. The second explanation is assimilation. Neanderthals could have assimilated into the Homo sapiens population. We do know that Homo sapiens and Homo neanderthalensis interbred, and it is plausible because our DNA contains small amounts of Neanderthal DNA. The third explanation is man-made. They could have been forced to extinction due to competition by Homo sapiens. Homo sapiens were able to make clothing which allowed them to compete with the Neanderthals in their colder climate. Essentially, Neanderthals could be the first species that mankind has pushed to extinction. So let's recap. We have Homo habilis, whose intelligence couldn't keep up with nature's demand, Homo erectus and Homo heidelbergensis, who have either linear paths of evolution or potential to succumb to solar radiation, and Homo neanderthalensis, who either had the fortune or misfortune of running into our species. The pattern is pretty clear here. It appears that intelligence drives progress and success. This means intelligence could be good or bad for a species. Habilis and Neanderthalensis, for example, were very successful due to their intellect, but only when there was no other being of equal or greater intelligence. So what can we infer from this? We could say that we are definitely the smartest species in our genus, and we may also conclude that if mankind were to ever meet an equal or greater intelligence, that it may not end too well for us.